Compiled versus interpreted languages. I'm trying to get a better understanding of the difference. I found a lot of explanations online, but they tend towards the abstract differences rather than the practical implications. Most of my programming experiences has been with Python, dynamic, interpreted, and Java, static, compiled. However, I understand that there are other kinds of interpreted and compiled languages. Aside from the fact that executable files can be distributed from programs written in compiled languages, are there any advantages/disadvantages to each type? Oftentimes, I hear people arguing that interpreted languages can be used interactively, but I believe that compiled languages can have interactive implementations as well, correct?
A compiled language is one where the program, once compiled, is expressed in the instructions of the target machine. For example, an addition plus operation in your source code could be translated directly to the add instruction in machine code. An interpreted language is one where the instructions are not directly executed by the target machine, but instead read and executed by some other program, which normally is written in the language of the native machine. For example, the same plus operation would be recognized by the interpreter at runtime, which would then call its own add A, B function with the appropriate arguments, which would then execute the machine code add instruction. You can do anything that you can do in an interpreted language in a compiled language and vice versa. They are both Turing complete. Both, however, have advantages and disadvantages for implementation and use. I'm going to completely generalize, purists forgive me, but, roughly, here are the advantages of compiled languages. Faster performance by directly using the native code of the target machine, opportunity to apply quite powerful optimizations during the compile stage. And here are the advantages of interpreted languages. Easier to implement, writing good compilers is very hard, no need to run a compilation stage, can execute code directly on the fly, can be more convenient for dynamic languages. Note that modern techniques such as bytecode compilation add some extra complexity. What happens here is that the compiler targets a virtual machine which is not the same as the underlying hardware. These virtual machine instructions can then be compiled again at a later stage to get native code, for example as done by the Java JVM JIT compiler.
A language itself is neither compiled nor interpreted, only a specific implementation of a language is. Java is a perfect example. There is a bytecode-based platform, the JVM, a native compiler, GCJ, and an interpreter for a superset of Java, BSH. So what is Java now? Bytecode compiled, native compiled or interpreted? Other languages, which are compiled as well as interpreted, are Scala, Haskell or OCaml. Each of these languages has an interactive interpreter, as well as a compiler to bytecode or native machine code. So generally categorizing languages by compiled and interpreted doesn't make much sense.
Start thinking in terms of a blast from the past. Once upon a time, long ago, there lived in the land of computing interpreters and compilers. All kinds of fuss ensued over the merits of one over the other. The general opinion at that time was something along the lines of: interpreter, fast to develop, edit and run. Slow to execute because each statement had to be interpreted into machine code every time it was executed. Think of what this meant for a loop executed thousands of times. Compiler, slow to develop, edit, compile, link and run. The compile/link steps could take serious time. Fast to execute. The whole program was already in native machine code. A 1 or 2 order of magnitude difference in the runtime performance existed between an interpreted program and a compiled program. Other distinguishing points, runtime mutability of the code for example, were also of some interest, but the major distinction revolved around the runtime performance issues. Today the landscape has evolved to such an extent that the compiled/interpreted distinction is pretty much irrelevant. Many compiled languages call upon runtime services that are not completely machine code based. Also, most interpreted languages are compiled into bytecode before execution. Bytecode interpreters can be very efficient and rival some compiler-generated code from an execution speed point of view. The classic difference is that compilers generated native machine code, interpreters read source code and generated machine code on the fly using some sort of runtime system. Today there are very few classic interpreters left, almost all of them compile into bytecode, or some other semi-compiled state, which then runs on a virtual machine.
The extreme and simple cases. A compiler will produce a binary executable in the target machine's native executable format. This binary file contains all required resources except for system libraries. It's ready to run with no further preparation and processing, and it runs like lightning because the code is the native code for the CPU on the target machine. An interpreter will present the user with a prompt in a loop where he can enter statements or code, and upon hitting run or the equivalent, the interpreter will examine, scan, parse and interpretatively execute each line until the program runs to a stopping point or an error. Because each line is treated on its own, and the interpreter doesn't learn anything from having seen the line before, the effort of converting human-readable language to machine instructions is incurred every time for every line, so it's dog slow. On the bright side, the user can inspect and otherwise interact with his program in all kinds of ways, changing variables, changing code, running in trace or debug modes. Whatever. With those out of the way, let me explain that life ain't so simple anymore. For instance, many interpreters will pre-compile the code they're given so the translation step doesn't have to be repeated again and again. Some compilers compile not to CPU-specific machine instructions but to bytecode, a kind of artificial machine code for a fictitious machine. This makes the compiled program a bit more portable, but requires a bytecode interpreter on every target system. The bytecode interpreters, I'm looking at Java here, recently tend to recompile the bytecode they get for the CPU of the target section just before execution, called JIT. To save time, this is often only done for code that runs often, hotspots. Some systems that look and act like interpreters, Clojure, for instance, compile any code they get immediately, but allow interactive access to the program's environment. That's basically the convenience of interpreters with the speed of binary compilation. Some compilers don't really compile, they just pre-digest and compress code. I heard a while back that's how Perl works. So sometimes the compiler is just doing a bit of the work and most of it is still interpretation. In the end, these days interpreting versus compiling is a trade-off, with time spent once compiling often being rewarded by better runtime performance, but an interpretative environment giving more opportunities for interaction. Compiling versus interpreting is mostly a matter of how the work of understanding the program is divided up between different processes, and the line is a bit blurry these days as languages and products try to offer the best of both worlds.
computerstrukturen.